right, I've pasted in here number 14 and number 15. You are assigned number 14, and I'm going to do number 15 and highlight what's the same about both of these problems. So I actually had done a little experiment with students a long time ago where I decided to teach every single problem as a word problem. Students can choose who they want to take in a civilian college, so I had a massive amount of drops when I made that announcement. But it eventually filled up because students needed to take that course to graduate. So I had some unwilling participants at the beginning, but I learned a lot from them, and they learned a lot from me with this experiment of how students read problems. So you kind of have to go where the student's looking at things, and the student looks at things from the numbers. So that's the first thing that catches their eye. So on number 15, if you look at the number, it's 200 milligrams that pops in. So if you try to place that number in context, I'm not even looking at the questions, I'm looking just at the number. It's 200 milligrams is the dose for an adult. And I see that same words up here, adult dosage for a drug is D. So what does that tell me? It tells me that D is 200 milligrams. They just hit it in the problem. And then they give me this formula, which has some numbers in it. And immediately, I think my eyes go to that next. I would imagine those students' eyes would go to that next. And if I go read what the C and A are, programmers actually have to write what words mean, letters mean, because it makes it easier for someone else looking at their code. So I would argue that that C should really be child dosage, and the A should really be age, so that someone else looking at it knows what it is. And so now that I've written out the formula with the D filled in, I see this child dosage is this formula here. And I'm going to clean this up a little bit. That 0.0417 times 200 is 8.34. And then I'm going to distribute in the 8.34 to be 8.34 times age. 8.34 times 1 gives me 8.34. And now I can answer the questions. So the first step is actually to read the problem, and read the problem from where you are coming from. If you're looking at the numbers first, start with the numbers and try to understand where those numbers fit in. So this is my Y, the child dosage, and that's my X. The purpose of this problem is to get you away from this pollution that we've been doing with you for years, talking about Y's and X's, and then really making it a real problem. I'm not sure that that's the right way to go, but let's run with this. If this was the Y and this was the X, then 8.34 is the M, and that's part A. What is the M? Newborn, the next question, what's the dosage for a newborn? Newborn is at age equals 0. So I plug that in, I get 8.34 milligrams. Interestingly enough, A and B have the same answer, except the slope is in as a rate. It's a dose per year. How do I know that? One of the failed things I think that we see is that unit analysis is really important. A child dosage is in milligrams. Age is in years. Whatever I multiply by, the units have to cancel and become milligrams. So how do I interpret this? Well, let's see if I can. I have to kind of do this up in the air. I should have actually done it for you, but if I go back here and look at this, if this is in years and this has to be milligrams per year, so the years cancel and then the end result is milligrams. So I know that this is going to be the dose per year of a child, milligrams per year. The units tell me that. Unit analysis is actually super important, and one of the first things I look at when I review a paper on modeling is I check all the units. And you'd be surprised how many researchers actually didn't do that as they're writing their model, make sure that their units match up. It's important. It's the first step of doing a good, writing down a good model. All right, so that's enough about modeling. Where does this come in for this other problem? Well, your problem doesn't have any algebra, so you don't have to do the algebra step that I did. The Y is T and the X is 2. The questions that are asked here are similar to mine. So I think you can answer that. Here, only thing I warn you is to be careful. 2100 is going to be a certain amount of years from 1900, so you don't have an X equals 0.